Welcome to Milak Online Tutorial. In this question, we are told to calculate for the maximum height above the ground, the time of flight, and the horizontal distance from the foot of the tower to Q. Now, if a stone is projected upwards at an angle of 30 degrees to the horizontal from the top of a tower of height 100 meters and it hits the ground at a point Q, a pictorial representation of this, to make it, so let's assume this is our tower. Now it's being projected and land at Q. Okay, now and our initial, okay, so the angle of projection here is 30 and our angle of projection, our velocity, so velocity is 100. Okay, we are told to calculate the maximum height above the ground, which means from here to here is what we need to calculate. But take note, since we've gotten from here to here, so let us calculate from here to here. Let us take this. This is the maximum height of projection. Okay, so here we have that h maximum height of projection is u square sine square theta over 2g. Now, and our g is taken as 10 meters per second. Alright, so here we can have that h equals to 100 square, then times sine 30 all square over 2 times 10. So here we have that this is 1, 2, 3, 4 times, this should be 0.5 sine 30. Sine 30 equals to 0.5. 0.5 square will give us 0.25, then over 20. This will eliminate this. 2 here, 1, 2 here, 500. So our height, if you multiply this by this, I'm sure it should give you 125 meter. So from here to here is 125 meter. Then the maximum height, which is in totality now, let us assume this is s. So our s here will now come and be h plus 100. That will be 125 plus 100, which will give us what, 225 meter. Alright, so the next thing now is the time of flight. Now the time of flight is the time taken for it. That will be t equals to 2u sine theta over g. Right, now if you have to plug in all the necessary parameters, so here you have that t equals to 2 times 100 times sine 30 over 10. So here we have that 0 cancels 0. So take note that sine 30 equals to 0.5. So here we now have that this is t equals to 20 times 0.5. So t will now be 10 seconds. Alright, now we are now told to calculate for the horizontal distance from the foot, from here down to here, from here down to here. Now here is a problem. Here our range, from here to here is the range, right? But here to here is the horizontal distance. Now take note of this, that from here to here is the distance from here to here is different from the distance from here to here. Why? Because we take cognizant here, you see that there is also a distance from here to here. Let us make this one. Let me say this is O and this is, let me say, P. So we need to calculate the distance. Now we'll calculate the distance, then we'll add up from here to here. But first, now since we know the time, now let us calculate the time from this particular point down to this place. Now take note, we know from here to here. Alright, now what we need to do first is to calculate for the time. I'm calculating the time. We have that s equals to ut plus at square over 2. Yes, and as such, now let us now input the necessary parameters. Here we have that the distance, which is the total distance from here to here, is 225. Now initial velocity here will be what? 0. Yes. Now plus our a here will be g, yeah, because it falls down, so it's in line with gravity. That will be 10, then times the time taken over 2. So here we have 225 equals to 2 here 1, 2 here 5, so we have 5t squared. Now if we divide both sides by 5, so 5 here 1, 5 here 1, 5 here 1, 5 here is 45. So our t square equals to what? 45. So our t here will now be the square root of what? 45. We will neglect the negative sign because we can't solve a value of t for negative sign. Alright, so the square root of now it is approximately 6.71 seconds. So from this point down to Q here, the time is 6.71 seconds. But take note, the total time of flight from here to here is 10, which means from here to here is 5, from here to here is 5. Okay, let me quickly redraw this diagram here for a better explanation. So for a better explanation, here is it. So it means from here down to this point, the time taken is 6.71. Now, but take note that the time of flight, which is from here to this point here, is 10 seconds. Right, 10 seconds, which means from here to here is 5, while from here to here is also 5. So from here to here, 5 seconds, and from here to here is 5 seconds. Now if from here to here is 5 seconds and from here to here is 6.17, so we can now say here 6.71 minus 5.00, so here we have 1.71 seconds. So from here, the time taken from here, from this place to this place, is time taken is 1.71 seconds. Now let's take note of this. Alright, now that we've gotten the time here, what we will now need to do is, now let us calculate the range from here to here, which is equivalent to from here to here. So our range here will now be u square sine 2 theta over g, and this will give us our velocity is 100 square, then times, this will be sine 60, so sine 2 times 30, then over g. Then our range here will now be 110,000, then times sine 60 here, this will be 60, so sine 60 here should give us 0.8660, then over 10, right? And as such, now this eliminating this, okay, we have 3 0 remaining, so this is 1 2 3, that will be 1 2 3, so our range here will now be 866.0 meter. Now take note, from here to here now is that. Now let us now calculate the distance from here to here. Now take note, with this now, let us work with let us calculate the velocity. So the horizontal velocity here, so it will give us u cos theta, and our u is 100, then cos 60 degree, and cos 60 degree should give us 0.5 if I'm not mistaken. Let me quickly do that. Sorry, guess here should be 30 and not 60. So here we now, this is 100 times 0.8660. Now multiplying the 0, 0, that's 2 0, that will be 1, 2. Let's move the decimal. You have 86.6 meter per second. Alright, now that we've gotten the range from here to here, we've gotten the horizontal velocity. Now what we all need to do now is to calculate for the distance from here to here, and the distance will now be, take note, the velocity here will take the horizontal velocity, and the time taken is from here to here, which is what, 1.71. So here you have 86.6 times 1.71. Now this should give us so here we have 1 multiplied through, we have 148.1 approximately. So here now is giving us 148.1, and here is, from here to here, is the same thing as the range. So the total distance, horizontal distance here, that's represented as horizontal distance, now give us the range 866.0 there plus 148.1. Now this should give us plus 866. So this should give us 1014.1 meter. Alright, that's the final answer to this question. If you love what I've just done, kindly subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos in physics, chemistry and mathematics. Thank you and God bless you.